This is the Chicago River at the confluence of Lake Michigan in the state of Illinois, USA. Most people would not notice anything wrong with this clip, but the river is actually flowing backward from its normal state. It's shown here flowing out toward Lake Michigan. I took these videos after a major precipitation event in April 2013. After witnessing the effects of heavy precipitation in the Chicago region, I was wondering if these events are increasing. To explain the unique river situation, let's briefly look at the topology of the area. Chicago rests near a mid-continental divide called the St. Lawrence Divide, shown in purple here. The divide lies a few miles to the west of the city. To the east of the divide, all water naturally flows towards Lake Michigan and the Great Lakes water basin. To the west of the divide, water flows towards the Mississippi River watershed and eventually the Gulf of Mexico. As Chicago grew in the late 1800s, sewage flowing out toward the lake and entering the water supply became a problem. In 1900, a series of locks was constructed, and the Chicago River was connected to the newly constructed sanitary and ship canal, which was cut through the divide. The river was thus reversed and now flows out toward the Mississippi River basin. The problem the city experiences now is during periods of intense rainfall, the Chicago River cannot drain toward the Mississippi River fast enough. To alleviate flooding, the city of Chicago opens the locks at the lake to allow it to drain to the east, back into the Great Lakes basin, in effect reversing the flow of the river. The problem is also compounded by the fact that stormwater runoff is mixed with raw sewage during these extreme rain events, as shown here. During the April 2013 storm that I mentioned earlier, I also spotted a United States Geological Survey crew collecting data on the flow rate of the river. They used a floating tool which scanned the riverbed to determine the total area and measured the velocity of the flowing water. How much is actually flowing out toward the lake during these events, and what is the pattern of these events? To answer that, I looked at the data collected by the USGS. Shown here is a graph of the flow rate of each reversal since 1985. Each positive value indicates a year where the locks were opened. Although the data doesn't go back very far, there is a slight indication that flow rates are increasing in recent years. Let's zoom out a bit and look at the region as a whole. This graph depicts the average annual precipitation for northeast Illinois using gauge data starting in the late 19th century. The data shows a slight trend upward beginning in the late 1960s and 70s. This is the total annual precipitation. The next figure analyzes whether the frequency of heavy storms in Illinois has changed between two periods from 1901 to 1980. A value greater than 1 indicates an increase in intensity. The figure generally shows an increase in intensity for the northern two-thirds of the state, including Chicago. So how does this relate to climate change? The theory is that as the Earth and its atmosphere warms, the air expands and can hold more water. Warmer temperatures also result in increased evaporation rates from the oceans. So you have a warm air mass with increased moisture content that can be triggered by a cold front and therefore result in more extreme precipitation events. Finally, here is a figure predicting changes in extreme precipitation events by the end of the 21st century. This figure was compiled from data in a new NOAA-led study that predicts an increase of at least 20% in probable maximum precipitation for a given day over the Chicago area, and a 20 to 30% increase over large portions of the northern hemisphere. Let's wrap up what we've gone over. The Chicago region has been experiencing increased stormwater runoff from heavier precipitation events, which has caused stormwater mixed with sewage to flow into Lake Michigan. The Illinois region as a whole has also experienced increased rainfall intensity and amounts over the last 100 years. Globally, the upward trend in rainfall intensity will continue as the Earth warms and can hold more moisture in the atmosphere, which precipitates back to the ground through more extreme weather events.